Welcome to Module 4 of the Certificate 4 of Project Management course, presented by Charter Australia. Module 4, Time, Cost and Resource Management. Time and cost are two of the key elements or project controls required for successful project management. However, time and cost cannot be determined without a knowledge of the resources, that is, people, equipment and materials, which are required for the project. Activities must be then sequenced, that is, put in a logical order. The most common relationships between activities are finish-start. That means the second activity cannot start until the first activity is finished. And start-start. Both the first and second activity must start at the same time. We will talk about sequencing in more detail a little bit later. Once we have defined our activities, we need to think about what resources we require to undertake these activities and what skills do we need. We also need to think about how much work effort is involved in each activity, that is, how much time is required to finish the activity. If we assign more than one resource to an activity, we can often shorten the duration of that activity, but we may increase the work effort. In other words, assigning 2 people to an activity with a work effort of 10 days will not necessarily reduce the duration to 5 days. This is because there are often overheads associated with 2 people working together. However, in order to complete a project as quickly as possible, it is good practice to assign as many resources as is practical to larger activities. Now that sequenced activities, resource allocation and activity durations are defined, a schedule can be created. A schedule is created through allocating start and finish dates to each activity, normally using special software such as MS Project. At this time, the schedule can then be adjusted to meet any predetermined milestones or resourcing constraints. At the same time, you can build up a cost estimate for your project. Usually the main project costs are for human resources. That is, multiply the cost of the resource by the amount of time required. Other costs, such as equipment, material, travel, etc., are then added on. Once you have a schedule and a cost estimate for the project, you can then create a time-phased budget by breaking down expenditure into monthly intervals. Project schedule. We're now going to go through the steps of creating a project schedule in more detail and learn how to use some useful tools. First of all, let us revise what is in a schedule. It shows all the activities in step-by-step order. It shows who will work on each activity, and it shows the time which will be spent on each activity. The work breakdown structure is the starting point for creating a schedule. break each work package into activities and create a schedule for each work package. Next, add in any dependencies between activities in different work packages in order to create a schedule for the entire project. We will use the work breakdown structure for the school fete which we developed in Module 3 for our scheduling example. Let us take the work package for ordering stalls and amusements and decompose that into activities. When creating a schedule, it is important to determine the duration of each activity. Firstly, you must determine the amount of work effort. Then you must determine how many people you can assign to that activity. The duration can then be estimated accordingly. Remember that work effort may vary according to the skills of resources available. Estimating work effort and duration should always be done in conjunction with subject matter experts who have had prior experience with that type of work. In this diagram you will see that each activity is numbered in the left-hand column. Firstly, we must select the location in the grounds and start planning, activities 1 and 2. We may need to analyze alternative layouts and different types of stalls and amusements, activity 3. Once we have made a final decision, we must then obtain approval from the headmaster, activity 4. The stalls and amusements must be ordered and deposits paid, activities 5 to 8. We have assigned the work effort and number of resources in the next two columns. In this particular example, all project staff will be working part-time, so the activity durations will be greater than the work effort. Next, we will sequence the activities. We call this defining dependencies. That is, each activity will be dependent upon the preceding activity. You can see that activity 1 does not have a dependency as it is the first activity. Activities 2 to 6 are all dependent upon the completion of the previous activity. However, it will be possible to order and pay the deposit for the amusements at the same time as we order and pay deposits for the stalls. In other words, these activities can be done in parallel. This means that activity 7, ordering the amusements, is also dependent upon completion of activity 4, the final decision. This slide shows a very useful tool for sequencing activities, that is, creating dependencies between activities, and is called a network diagram. Schedule development should always be done collaboratively with subject matter experts. A network diagram is a very useful workshop tool to enable you to develop the first cut of your sequence activities before you key it all into your scheduling package. This is particularly important for more complex work packages. If you write every activity on a post-it note and use a large whiteboard or even the wall of a meeting room, you will find that arranging activities into sequence is much easier and also more fun as it promotes interaction between the group. Remember that you should aim to do as many activities as possible in parallel in order to shorten the total duration of your project. Of course, you must ensure that this is logical and that you also have enough resources to do the work. The network diagram on this slide has been developed using the dependencies applied to the order stalls and amusements work package. You will also note that the activity durations are written above each activity. finally, we need to calculate the critical path. The critical path is the shortest possible completion time for the work package or project. An activity on the critical path has what we call zero float. This means that if an activity on the critical path is delayed, the whole project is delayed. The next slide will illustrate this concept. Note that there are two pathways through this work package. Pathway 1 consists of activities 1 to 6 along the top. Pathway 2 consists of activities 1 to 4 plus activities 7 and 8 on the bottom. A total duration for the pathway 1 is 33 days, whereas the total duration for pathway 2 is 35 days. The project cannot be done any quicker than 35 days, therefore this is the critical path. If any of the activities on pathway 2 are delayed, then the whole project will be delayed. However, activities 5 and 6 in pathway 1 have a total of 2 days float. This means they can be delayed by up to 2 days without delaying the project. The critical path is a very important concept for monitoring schedules, as the project manager must carefully monitor all activities on or close to the critical path to ensure that the schedule does not slip. The Gantt chart. This is the most common form of illustrating a schedule. It is a two-dimensional representation of the project schedule with activities down the rows and time across the horizontal axis. It's used during planning, resource scheduling and status reporting. This is a Gantt chart of our order stores and amusements work package produced from the MS Project scheduling package. Each bar shows the length of each activity. Dependencies between activities are shown by arrows, and the critical path is shown by the red bars. You will also see the names of the resources listed against each activity. Estimating techniques. Because there is a degree of uncertainty when we are creating change via a project, we can't always be 100% certain that we've covered every eventuality. Sometimes an activity may take longer than expected due to circumstances beyond our control, or because we just underestimated the amount of work involved. In order to cover these situations, we use the concept of contingency. This means that we add some extra time into our schedule to cover unknowns. If we don't use the contingency, then we will finish early. It's best practice to place special contingency activities in your schedule and use that time only if necessary. If you add contingency to every activity, then human nature is such that they will always use the time allocated and it will be of very little benefit. By adding a 10% contingency into our order stalls and amusements work package, we've added 3.5 days to the project duration. Typically, the contingency used in project estimating can vary from 10 to 25% depending on the degree of certainty. For example, if you're using new technology for your project, then you would have a higher contingency than if you're doing something very similar to what you've done on a previous occasion. The next estimating technique is using comparison with previous projects. If an activity or work package has been done previously on several occasions, it can save a lot of time if you use previous estimates for your scheduling. This is commonly done in the building and construction industry. It should, however, be used with care if the conditions or methods are not exactly the same, and it still may be wise to add contingency in to cater for unexpected circumstances. The third estimating technique is parametric estimating. Parametric estimating is commonly used in building trades, where average times to perform an activity can be applied. For example, an experienced bricklayer can lay 750 bricks per day on average. The fourth estimating technique is called resource leveling. This is a very important technique. It's used to optimize the use of resources on a project. Resource planning should aim to utilize resources in a consistent manner so they are consistently productive, not busy one week and nothing to do the next. It's important that project staff are allocated to activities for the prescribed number of hours per day and do not have periods with nothing to do. This is both costly and also demotivating for the team member. Once you have developed your schedule, always review your resource allocation and make adjustments, especially where resources are under or over allocated and conflicts occur. Scheduling software packages such as MS Project have tools which assist with resource leveling. Schedule monitoring. During the project, progress must be monitored against the original or baseline schedule. You need to document how much work has been done and, just as importantly, how much work still needs to be done. Forecasting is critical to understanding how well your project is progressing. If there are any deviations from your baseline schedule, you will need to document these and then recommend corrective actions. The most common ways to bring a project back on schedule are working overtime and adding more resources. Of course, both these solutions add to the cost of the project. The other method is to reduce scope, but this means that you won't be delivering as much functionality to your customer. All of the above solutions, of course, must be approved by management and should be formalized using the change control process. Once we have a clear picture of the work effort and resources required to do each activity of each work package in the project, we are able to estimate the cost of the project. For most projects, the major cost is human resources. Other costs which must also be considered are equipment, material, and extra costs such as travel. These are all direct costs. That means they are costs which are directly attributable to the project. When creating your cost estimate, you must also consider indirect costs. These are costs which are not specifically incurred by your project, but must be included in order to pay for the cost of running your organization's business. Examples of indirect costs are management overhead, shared services such as the HR and accounting departments, or the cost of occupying floor space and using electricity, etc. Contingency should also be applied to cost estimates and will depend upon the level of risk associated with those cost estimates. For example, a fixed price contract will typically have a very high level of contingency compared with a time and materials contract. This is because fixed price estimates are much higher risk than time and materials. Other risks may be contractual. For example, penalties for schedule overruns or the risk associated with producing the required quality deliverables. Use of leading-edge technology is also a very important factor when planning contingency due to the high probability of unanticipated problems for which solutions may not always be readily available. The level of cost contingency will depend upon all these factors and is usually dictated by company or project methodology policies. Once you have developed a cost estimate for your project, You should then break down the expenditure by month, depending on when you expect to incur those costs. A cost estimate becomes a budget when it is broken down into time intervals. The next slide will show you an example of a time-phased budget. This slide shows an example of a budget. On the left-hand side you can see the various cost categories. On the right of those, the costs are broken down to the expected expenditure for each month. This enables project expenditure to be planned and tracked on a monthly basis. Monitoring costs. This slide shows you an example of a consolidated expenditure spreadsheet for a point of time in the project for the FATE example we referred to earlier. The information in this cost summary would be developed from a more detailed spreadsheet showing costs for every work package. The example in this slide is typical of what you would include in a status report for your sponsor. Notice that it is very important that you not only record expenses to date, you must estimate future expenditure for your project. This is called forecasting. An honest forecast allows you to identify problem areas and plan for corrective action before it is too late. Remember, it's always important to think ahead when monitoring both cost and time. This ends Module 4, Time, Cost and Resource Management. You now need to complete the following assignments for your case study project and submit them to your tutor: a work breakdown structure, schedule and budget. Please refer to the case study, assignment instructions and supporting templates.